Now we will start with the value of a polynomial at a point. Now you have all understood what is a polynomial. A polynomial is an algebraic expression having many terms. What is a special condition on the variable? The power of the variable should be a non-negative integer. So now let me assume any polynomial, say px is equal to 3x square minus 5x plus 6, any polynomial I have assumed. Now in this entire polynomial, x is the only variable. Variable means the one which can change its value. The other numbers like 3, 5, 6, they are all constants. We cannot change their value, but the only value that can be changed is of x. So suppose for x is equal to 1, I want to find the value of the polynomial px. Then what will I do? P of 1. In place of x, I will be putting the value 1. Similarly, in the entire polynomial, in place of x, I will be writing 1. So this gives me 3 minus 5 plus 6. Now 3 plus 6 is 9 minus 5, which is equal to 4. It means the value of the function px at x is equal to 1 is equal to 4, and it is represented as p1. Similarly, if I write, suppose if I write p of 2, what does it mean? This would mean value of the polynomial px at x is equal to 2. And how will you find out p2? Simply by putting the value of x as 2 in the entire polynomial, because that is a variable. Variable means that number which varies in its value. So we can give different values of x in the polynomial. So that gives us 3 into 4 minus 10 plus 6, 12 minus 10 plus 6, which gives you 12 plus 6 is 18 minus 10, which is equal to 8. So the value of the given polynomial at x is equal to 2 is equal to 8. Now suppose I take another polynomial, say px is equal to x square minus 4x plus 4. And suppose I want to find the value of this polynomial at x is equal to 2. Then I will replace x with 2 everywhere in the polynomial, and we will get 4 minus 8 plus 4. Now this 4 plus 4 makes 8 minus 8, which gives you 0. So in this case we have got p2 is equal to 0. It means that x is equal to 2 is that value of the variable x which makes the polynomial px equal to 0. Means when I put x is equal to 2, that means p2, that is coming out to be equal to 0. So x is equal to 2 has made the polynomial 0. Therefore we can say x is equal to 2 is a 0 of the given polynomial. This is known as a 0 of the given polynomial. You have understood what is the meaning of 0 of a polynomial? That value of the variable which makes the polynomial 0 is known as a 0 of the given polynomial. Now let us take one more polynomial. This time I am taking this polynomial as this. So can you tell me what kind of polynomial is this? If I open it out, multiply the two brackets, I will be getting x square as the highest power of x. So it will be a quadratic polynomial. And you know, quadratic polynomial has two factors. So this polynomial is actually given in the factorized form. Now I want to find out the zeros of this polynomial. Now what is the meaning of 0? It is that value of the variable which makes the polynomial 0. So just by looking at the polynomial carefully, can we say that if I put x is equal to 1, say p of 1, if I find out, what will I get? 1 minus 1, and here 1 plus 2. That gives me 0 into 3, which is equal to 0. It means if I put x as equal to 1 in the given polynomial, the polynomial is reducing to 0. That means x is equal to 1 is a 0 of the given polynomial, that is px. Similarly, now if I put x is equal to minus 2, I am just looking at these two factors and trying to make them 0 one by one. Initially I made this 0 and now I am going to make this as 0. So that is going to happen only when I put x is equal to minus 2. So if I put x is equal to minus 2, what is the value of p of minus 2? Let's see. Minus 2 minus 1 and then minus 2 plus 2. Minus 2 minus 1 will give me minus 3 and this is 0, which gives me 0. It means x is equal to minus 2 is a 0 of the given polynomial px. If I actually want to know what this polynomial was, if I don't write it in the factorized form, this polynomial was x square plus x minus 3. If I would have given you the polynomial in this form, in the quadratic form, without factorizing, it will be difficult for you to find out for which value of x this polynomial will reduce to 0. In that case, you will have to do the hit and trial method. So what we do is, whenever there is a quadratic polynomial, we first try and write it in the factorized form. And then by looking at the factors, we can easily make out what is the 0 of the given polynomial. Now let's take one more example. Say px is equal to x plus 3 into x minus 4. Again, it is a quadratic polynomial. If I write on the actual form of this polynomial, it will be x square minus x minus 12. But you can easily see, if I put the values in this unfactorized form, it will be very difficult for me to make out what are the zeros of this polynomial. But once I have factorized it here, I can easily make out that if I put x is equal to minus 3, you can see the first bracket. If I put x is equal to minus 3 here, minus 3 plus 3 will become 0. So the entire polynomial will reduce to 0 just by making one of its factors as 0. So now let's check out. P of minus 3 will be minus 3 plus 3 and then minus 3 minus 4. That gives you 0 into minus 7, which is equal to 0. So can I say x is equal to minus 3 is a 0 of the polynomial px? Also, now if I put x is, now I am trying to make the other factor as 0, x minus 4. Which value of x will make this bracket 0? If I put x is equal to 4. So now let's check out what is p4 equal to. That is equal to 4 plus 3 into 4 minus 4. That gives you 7 into 0, which is equal to 0. Hence I can also say x is equal to 4 is a 0 of the given polynomial px. Okay, now let's take, so just observe one thing. When it is a quadratic polynomial, we have two zeros of the given polynomial. So the degree is 2. When there is 2 degree, there are 2 factors and hence 2 zeros. But it is not always possible. Suppose I take another example of a quadratic polynomial where you will not get 2 zeros. Suppose I take an example x square minus 4x plus 4. Again, as I told you, unless and until I factorize it, it will be difficult for us to find out the zeros of a given quadratic polynomial. If it is a linear, we can directly find out. If it is a quadratic, we must factorize it to find out the zeros. Now, what is the factorized form of this? Middle term splitting you all have done till class 8th. So, if I split it, I'll get x minus 2 into x minus 2. That means x minus 2 whole square. Now, which value of x will make this polynomial 0? Obviously x is equal to 2. So p of 2 will come out to be 2 minus 2 into 2 minus 2, which is equal to 0 into 0, which is 0. That is the only value. Though it was a quadratic polynomial, but it has only one 0, that is 2. Now suppose I take one more quadratic polynomial, say x square plus 1. Now can you think, do you think that we can factorize it? No. Had it been px is equal to x square minus 1, then you would have written it as x plus 1 into x minus 1 by using the identity a square minus b square. In this case, can you just guess the two zeros orally? If I want to make this bracket 0, I will put x is equal to 1. And if I want to make this bracket 0, I want to put x is equal to minus 1. So I can easily say 1 and minus 1 are the zeros of this polynomial. Now, but if I talk about this, px is equal to x square plus 1, we cannot factorize it as such. And can you think of putting any value of x here which makes this polynomial 0? If I want to make this polynomial 0, then obviously I need one negative and one positive value. One is already positive, so it means the first term, that is x square, should be negative. But is it ever possible that the square of a number is negative? You put whether negative value of x or a positive value of x, answer will always come out to be positive. And you know, two positive numbers can never give you 0. It means that there is no 0 for the given polynomial px. So could you see, if I take px equal to x square plus 1, or if I take a polynomial as x minus 2 whole square, or if I take a polynomial as x minus 2 into x plus 3, all these three are quadratic polynomials, but in this case I got two zeros, in this case I got only one 0, in this case I got no zeros at all. Can you think of a quadratic polynomial having three zeros? That is not possible, because maximum zeros that a quadratic polynomial can have is 2. So we can't say that the quadratic polynomial has exactly two zeros. We will say a quadratic polynomial has at most two zeros. At most means maximum. It can go lesser than 2, but maximum is 2 only. Less than 2 is possible, but more than 2 is not possible. So we say quadratic polynomial has at the most two zeros. Similarly, if I talk about a cubic polynomial, I'll take three different examples. One is x minus 1 into x minus 2 into x minus 3. If I multiply these three, obviously it will come out to be a cubic polynomial. Second polynomial, I take it as x minus 1 whole square into x minus 2. And the third polynomial I am taking as x minus 1 whole cube. So in the first case, you can find out three values of x for which you can make this polynomial 0. That means x is equal to 1, x is equal to 2 and x is equal to 3. So there are three zeros for this polynomial. In the second case, you can find only two values of x for which this polynomial is 0. One is x is equal to 1, the other one is x is equal to 2. In the third case, there is only one value of x for which this polynomial can reduce to 0, and that is x is equal to 1. So a cubic polynomial can have either 1 0, 2 zeros or 3 zeros, but not more than 3 zeros. So I can say a cubic polynomial has at the most 3 zeros. And if I take a linear polynomial, say px is equal to 3x plus 2, what can you think of? What will be the zero of this? Directly, orally, if you can't find out, what you can do is you can put the polynomial equal to 0, so that you can find the value of x, which is minus 2 by 3. That means x is equal to minus 2 by 3 is the 0 of the given polynomial px. It's a linear polynomial, it has only one 0. So if it is a linear polynomial, it has 1 0. Quadratic polynomial, it has at most 2 zeros. You can't say it has 2 zeros always. You can say at most 2 zeros. If it is a cubic polynomial, you will say at most 3 zeros. Similarly, if I say it is a biquadratic polynomial, then we will say at most 4 zeros. Now suppose if I ask you how many zeros a polynomial can have if its degree is 10, 10 degree polynomial, degree 10, then how many zeros will it have? It will have at most 10 zeros. So in general, if I say the degree of the polynomial is n, nth degree polynomial, how many zeros will it have? It will have at most n zeros. I hope this concept is clear to you now, that number of zeros depend upon the degree of the polynomial. If the degree is 1, it will always have 1 0, but if the degree is more than 1, if it is 2, we'll say it has at most 2 zeros. Third degree means at most 3 zeros, fourth means at most 4 zeros, and so on. If it has nth degree, where n can be any number, if it has nth degree, it will have at most n zeros. Now let us start with the exercise 2.2 of your NCERT book. Now the first question of exercise 2.2 is, find the value of the polynomial 5x minus 4x square plus 3 at x is equal to 0, x is equal to minus 1 and x is equal to 2. This is your question. Now children, remember one thing, whenever any question on polynomial comes, first thing you must do is to name a polynomial. Now you all know what is the notation for a polynomial. I can say let p of x represents the given polynomial 5x minus 4x square plus 3. Remember one thing, had this polynomial be like this, then how will you name it? Then in that case you will not name it as px, but you will name it as py, because here we always use the variable which is used in the given polynomial. So I have named this given polynomial as px. Now the question is, find the value of this polynomial at x equal to 0. So what do I have to do? I just have to put x equal to 0 in the given polynomial. So wherever you see x, you just put 0 in place of x, and then you will get the value of the polynomial at that point. So the answer is 3. Value of the given polynomial at x is equal to 3 is equal to 3. Similarly, value of the polynomial at x is equal to minus 1, that is the second part. So what will I write? P of minus 1. I will replace this x and this x, all the x, by minus 1. 5 into minus 1. See, 5x means 5 into x. So I will write 5 into, what is the value of x? Minus 1. So 5 into minus 1 minus 4 into x square, so into minus 1 square plus 3. Now let's solve it. 5 into minus 1 gives you minus 5 minus 4 into minus 1 square. What is minus 1 square? It will be plus 1. Minus 1 square is minus 1 into minus 1, which is plus 1. So minus 4 into plus 1 will be minus 4 plus 3. That gives you minus 9 plus 3, which is equal to minus 6. Similarly, the third part is x is equal to 2, which you can try out on your own. Now look at the second question, that is, find P0, P1 and P2 for each of the following polynomials. So now let's take, they have already named the polynomials in this case. The first is named as py, which is equal to y square minus y plus 1. And for each polynomial you have to find three values, p0, p1 and p2. So I hope this is very much clear to you what you have to do. You just have to replace y with 0 for the first part, second part replace y with 1, and for the third part replace y with 2, and you will get the three values. Similarly, in the second part, another polynomial is given, p of t is equal to 2 plus t plus 2t square minus t cube. You just have to find out p0, p1 and p2 again for this polynomial. So simply by replacing t with 0 for the first part, t with 1 for the second part and t with 2 for the third part. In the same way you can complete question number 2. It's very simple, just finding the value of the polynomial at the given point. Now coming over to question number 3. Third question says, verify whether the following are the zeros of the polynomial indicated against them. Now here px is equal to 3x plus 1 and x is equal to 1 by 3. Children, in this case you are not supposed to find the zeros of the given polynomial. You just have to check out whether the given value of x, like here in this case x is equal to 1 by 3. You just have to check out whether this is a zero of the given polynomial or not. It is called verification, not finding. So I have to verify. So what will I do? I will put the value of x as 1 by 3 in the entire polynomial and I will see what is the value coming out. It is coming out to be equal to 2. It means if I put x is equal to 1 by 3, the value of the polynomial is coming out to be 2. So 1 by 3 is not making this polynomial a zero polynomial. That means x is equal to 1 by 3 is not a zero of the given polynomial px. Let's take one more part. Second part, it says the polynomial is px is equal to 5x minus pi and x is equal to 4 upon 5. Again I have to check out whether x is equal to 4 upon 5 is a zero of the given polynomial or not. And how can we check out? By putting the value of x in the given polynomial. And if that value makes the polynomial 0, we will say yes, it is a zero of the given polynomial, and if it is not able to make it 0, we will say it is not a zero of the given polynomial. So here we are getting the value as 4 minus pi. Pi you already know is either 22 by 7 or 3.14. So obviously it is not equal to 0. It may be any value but at least not equal to 0. So therefore x is equal to 4 upon 5 is again not a zero of the given polynomial px. Take one more example. Say px, third example I am taking, px is equal to x square minus 1. Now for x is equal to 1 and minus 1, they have given you two values and you have to check whether they are the zeros of the given polynomial or not. So let's first check out for 1. If I put x is equal to 1, I will write 1 square minus 1, which is 1 minus 1, which is 0. If I put x is equal to minus 1, again I am getting minus 1 square, and minus 1 square will be 1, again minus 1 equal to 0. It means both the values of x are making the given polynomial 0. Therefore, can we say x is equal to 1 and minus 1 are the zeros of the given polynomial px? Yes. So this is how you have to complete the rest of the parts. By putting the values, see whether the polynomial is reduced to 0 or not. If it is coming out to be 0, then we can say yes, it is a zero of the given polynomial, and if it doesn't come out to be 0, you will say it is not a zero of the given polynomial. Now the last question, that is question number 4, is find the zeros of the polynomial in each of the following cases. It's a very simple example for you now because we have done much tougher questions than this in the examples. Okay, so if px is equal to x plus 5, I just want to find the value of x which can make the given polynomial 0. Obviously, for linear polynomials, just by looking at the polynomial, you can make out it will be x is equal to minus 5 in this case. But the method is you just put the polynomial equal to 0 and see what is the value of x coming out, minus 5. So you can say x is equal to minus 5 is a 0 of the given polynomial px. Okay, let's take one more example. Say px equal to 2x plus 5. What is the 0 of this polynomial? Directly, if you can't think of, just put the polynomial equal to 0 and find out the value of x. It is coming out to be minus 5 by 2. Therefore, we can say x is equal to minus 5 by 2 is a 0 of the given polynomial px. In fact, all these polynomials given in this question are linear polynomials. So definitely there is going to be a single 0, means 1 0 for all these polynomials. And I think now you can try out the rest of the questions, rest of the parts of question number 4 as well. And you can complete this exercise 2.2.